than non-golfers. And you could say, well, maybe that's part of it. That, if you get around a golf course, that's going to take you an hour or two. That's a way of getting a heavy dose of natural light.
This all points to the fact that we have to be extremely intentional with our light environment. The same way that many people here are thinking about the food that they're eating, are conscious about not over-consuming calories, are trying to do their best and choose organic and stay away from maybe some of the harshest chemical pesticides that are out there. In that same sense of diligence that we have in what we put in our body, we have to bring that diligence to light because our health literally depends on it. I want to switch topics for a quick second here, and I want to go to the topic and the connection of blue light and obesity. What have you found out through your years of looking at the literature that's out there?
Well, we've done a lot of looking at the literature, and we've also done a lot of studies now, both in the lab, but also in the workplace. And what's really interesting is when you look at people who are under blue-rich, that means standard LED, standard fluorescent lighting at night, they are, number one, they have more hunger, they have a higher appetite. They actually snack in the workplace twice as many snacks on the night shift than if you give them light that doesn't have any blue in it. So there's an appetite part of the problem. Then there is the fact that if you look at the insulin glucose axis, in other words, metabolic measures, and you test like a glucose tolerance test, for example, where the standard test for diabetes, where you drink a bottle of sugar water and then every half hour or so, the doctor takes a blood sample and they track how the insulin, glucose and insulin levels rise, and then they fall back down if you are healthy, back to normal levels by the end of 2 hours. If you've got diabetes, those levels climb higher and stay higher. We find that when people are under regular LED lights, the standard LED lights, conventional lights that you buy in the store, that they get pre-diabetic, even the first perfectly healthy person in the first night of exposure. And so by the morning, they've got a diabetic type glucose tolerance test. And so we're adjusting, we're having big effects, therefore, on the fundamental mechanisms of not only snacking, but also how substances are metabolized in the body. And you're creating this metabolic syndrome, in real time, just by being exposed to blue-rich electric lights.
Let's pull on the thread for our audience of a little bit of how are all these things happening from being exposed to the wrong light at the wrong time. And specifically, I'd like for you to unpack the idea of this master switch that's in the brain that you were a big part of the team of helping us discover. Can you talk about that?
Absolutely. The circadian rhythms of our body are all those functions of the body that go up and down with the time of day. So cortisol peaks, for example, just before dawn, melatonin peaks at 2 a.m. in the morning, other rhythms, growth hormone peaks just when you go to sleep. There are all these rhythmic patterns of body temperature goes up and down. They're all called circadian rhythms. They are not products just simply of our environment and what we're going on outside and what we're doing. They're actually driven by a master clock in the brain and then lots of clocks, millions of clocks in every cell and tissue of our bodies. Now, that was, first of all, studied in animals. But when I first started in the field, it was assumed, in fact, the leading scientists at the time thought that humans did not have a master clock. It's called the suprachiasmatic nucleus, by the way, SCN for short. The acronyms are useful because of the mouthful. And the suprachiasmatic nucleus was found in various animals. It was found in 1972 in rats and then in hamsters, but no one could see it in the human brain. And one of the things our team did was one of my postdocs actually realized that when you're looking at atlases of the human brain, that they are showing you every 50th slice of the brain and throwing out 49 slices in between. So you're only getting a sort of a snapshot of one slice through the brain, and they slice it through systematically and show it as a map. But if there's a small entity like this suprachiasmatic nucleus, then you're going to miss it. So Ralph Leidig, my postdoc, went back and looked at all the 49 slices in between, and lo and behold, consistently there was this same structure that was seen in rats and hamsters and monkeys and elsewhere. So yes, humans did have a suprachiasmatic clock wired in the same way, with a pathway coming back from the eye, from the back of the eye, from the retina, through a so-called retinohypothalamic tract, which lit direct pathway into this suprachiasmatic nucleus. And given that that clock is the fundamental thing that keeps everything in timing, that's a really fundamental part of the system. Now, I mentioned millions of other clocks. The problem is if the master clock is not being adequately synchronized by bright blue light during the daytime and absence at night, then it gets out of sync and the signal becomes weak, and the various functions of the body all start getting out of time with each other. And I've likened it to a discordant orchestra. If the conductor is not guiding the orchestra, the conductor being the SCN clock, then of course you get this really discordant sound. For the body to be harmonious and to be healthy, everything needs to be tightly in sync and with a robust amplitude, in other words, a strong beat to this system. And you only get that if you're exposed to bright daylight during the day and pitch darkness at night. And that